You're good to go.
Hello, everybody. My name is Toan Tran with Coast Colleges. Can you hear me okay?
I can
Yes,
hear you
we
fine.
can.
Awesome. Thank you. Today, I'll be sharing with you our implementation of Security Onion and also going over some of the different tools that are included in the package. So this neat little software package was created by a gentleman named Doug Burke, who founded Security Onion Solutions. And they also have a catchy tagline that's on the screen there. It says, peel back the layers of your enterprise and make your adversaries cry. So the software is available for download in a bootable installer. It's completely free. It also has a package installer if you already have an existing Ubuntu or CentOS Linux installation. And then Security Onion also has a premium plan that we can basically buy time, support time at the per hour rate. I like to think of Security Onion as a toolbox rather than a tool. This is because it bundles a bunch of several useful open source security tools into an integrated package. And you can set it up in either as a standalone or distributed mode where you have multiple computers or servers hosting the same, collaborating. So the package itself uses Docker containers to run the different services. And if you're on a distributed network, it uses a framework called the Salt Stack to allow you to do your configuration on just a manager node, and then it'll just push the configuration down to the different nodes. You can drill into the different containers if you feel like it, but I don't recommend it because when it does its update, it may replace the containers and you will lose your changes if you start customizing the containers. So from my experience, not only does Security Onion have a relatively low learning curve, but the package itself is pretty resilient. It has a little self-correction logic in there that basically fixes itself when there is an integrity or a configuration problem. So some keywords to get out of the way. We're going to use NIDS and HIDS a lot. NIDS is a short for Network Intrusion Detection System, and HIDS is short for Host Intrusion Detection System. The Network Intrusion Detection System basically monitors network traffic, whereas the Host Intrusion Detection System is basically just a log monitoring to detect intrusions into the host or a server. And as I mentioned before earlier, Security Onion pulls together several popular security packages and aggregates the alerts into a cohesive single pane of glass view. And this is how we have it set up. So on the left, in the NIDS section, in the NIDS section, we have the network with the different taps at different locations in the network, and they feed to the sensors. Originally, we had a problem with if a packet goes through different taps, it would get reported by the different taps, and then we would have multiple duplicated information in the manager. So to remedy that, we put in a deduplicator called a Gigamon, it's a fairly expensive hardware. It basically takes all of the traffic and aggregates them and basically remove duplicate records. And then it feeds them to the different sensors in a more load balanced manner. And on the right, you have your HIDs, your host intrusion detection system, which are basically just a client that runs on the servers and analyzes the logs and feed them straight to the manager. So HIDs does not go through the sensors. And on the sensors, you have a few cool things that run on it. You have your full packet capture, which basically tracks and captures all the packets, and all your worker processes, your packet inspections also run on the sensors. And then they feed all the metadata to the manager, which is your main access point for configuration and console. And you have your search node, which is a helper node that helps basically offload the processing of indexing and all that data for the manager. Let's talk a little bit about the worker processes. So you have your full packet capture, which is one of the main features of Security Onion. It runs a process called stenographer. And what stenographer does is it listens to the interface and it basically just captures everything that gets fed to it and logs it into packets. Next, you have your NIDS processes, which is your network intrusion detection processes. I don't know which order they're in. They process the packets in, maybe they do them concurrently, but I'll just go down the list. You have first your Zeek or Bro process, which basically looks at the packets and says, and logs a bunch of data, metadata attached to it. For example, if it sees it as a DNS traffic, it'll log the type as DNS or HTTP, and it also log stuff like IP addresses from, to, and timestamp and everything else. It's not an alerting engine. It's just a meta tagging engine. And then you have your Suricata, which is your alerting engine. Basically, it's like an antivirus where it has its predefined signatures, and then it matches the packet with the signatures. And if it finds something that it finds suspicious, it's going to log the alert. And these signatures can range from policy violations to policy violations to malware to anything suspicious like a control and command target and everything else. And then another scanner we have is a Strelka. Strelka is more like a file scanner. It will scan files that go across the traffic, and it will also alert if it finds malicious files that matches its hashes that is stored. And the next we have your HIDs. As we saw earlier in the diagram, it doesn't report to the sensors. So it just basically runs a client called Wazoo in its servers and sends them directly to the manager, which has the Wazoo server, which then processes those logs, just like how Suricata processes the packets. And at the very heart of everything is Elasticsearch. It sits on the manager, or if you have a distributed network or distributed setup, it'll sit on the search node. Basically, it stores all the metadata that is sent to it, and it will also index it in a way that we can search for it or query the data from it if we need to. So you may ask yourself, if all these tools are free and available, why do I need Security Onion? Right. The neat part of Security Onion is it ties all these tools together into one console. So you don't have to open each tool to view their alerts. And basically, you don't even have to go through learning each tool. You just need to learn the Security Onion. And here's what the menu looks like. At the top, you will have different threat hunting tools. And on the bottom, there are independent tools that are not part of Security Onion, but they're packaged as a convenience. All right, first, we have your alert screen. This is where we start our days with if we are managing or monitoring Security Onion. This is your single pane of glass. It aggregates all of the different alerts from different modules and presents them in a table with the fields that are common to the alerting modules, such as severity, alert name, occurrences. And of course, in the module section, it will tell you which module is reporting that alert. You can do some basic functions here, such as filtering for specific values. So you can drill down into their values. And you can acknowledge the alert telling the system that, hey, I know of this. So basically just hide it from my view for now. Or you can escalate it, which sends that alert or that specific event to the case manager, which we'll look at in a few minutes. Next, we have your hunt screen. The hunt screen is more of an extension of the alert screen. It allows you to do more filtering. It has an open text box at the top where you can type in your different filters, groups, and everything else. In the hunt screen, you will also have your Zeek data, which was not present in the alert screen. So this gives you a more in-depth view of basically your target that you're hunting. So let's say if you want to check all the traffic that goes from a certain source IP to a certain destination IP, it will give you all of those. Kibana is more of a visualizer. It's similar to the hunt screen, whereas the hunt screen would draw data from Elasticsearch to present it in a threat hunting purposes, whereas Kibana is more of a network traffic visualizer. It gives you more overview or analytics to the different traffic that is, or the different data that is in Elasticsearch. So, and then you have your cases, which if you're in the alert or hunt screen, you can escalate events into cases. And here you can track different things in it, such as observables, events, and assignments to different people within Security Onion. So from either your alerts or hunt screen, you can also request a packet capture, which in short, we call it a PCAP. If the system can find a packet capture for a requested traffic, it'll display it in the PCAP screen. Basically, it will query the Elasticsearch, and then it'll query the sensors to draw the packet capture. If it doesn't find it, it'll tell you it can't find the packet capture because some events do not have packet captures. And then from here, it gives you a little preview of what the packet looks like, or you can also download it if you want to use a more robust tool like Wireshark. Next, you have your grid. Basically, this is an overview of the system status. It will tell you the status of the different nodes in your setup. So here we have the name, the information of the different information for that node. And on the right, you have your status. You could log into each status and do an SO status, and it'll report to you the different statuses for different components. But the grid will give you a quick overview of how your nodes are doing. If you want a more detailed look, there's a Grafana tool. This gives you much more details on the different things that are happening in your grid. You can have container status, CPU status, memory, input traffic, packet loss, and everything you can think of is in the Grafana view. Plus, it looks cool with different charts and graphs and stuff. Next, we go to CyberChef. CyberChef is not necessarily an integrated tool, but it's more of a quick, handy tool, more like a calculator, where you can encrypt, decrypt different or encode or decode different strings, change bases, and some arithmetic logic and everything else. And last but not least, you have your attack navigator, which is basically just a quick reference to the MITRE attack matrix. What else can we do with Security Onion? So first thing we noticed was all the alerts, metadata logs are conveniently stored on the sensors under the NSM folder. And also the HIDS logs are stored under NSM folder on the manager node. From there, we could grab those logs and send them directly to the different SOC services if we have external SOC services like Splunk or Milton. Also, if you have programmers on staff, you can write scripts or programs that access those logs directly. They're just in JSON format, and do your own automations and analytics without even having to use the console. And more excitedly, you can query Elasticsearch directly and add your own automation. It'll basically save you from having to do some things manually on the console. For example, you can query it to find events that have been acknowledged often, such as SMB traffic from a NAS. With that data, you can automatically or programmatically create an exception rule to tell Kibana to basically stop alerting on such events because they have been passed over so many times that they're not needed anymore. And that concludes my presentation on Security Onion. If you have any questions, please email me at that email address. And at this point, I'd like to open the room up for discussions.
If anyone have any questions, please feel free to put in a chat. If not, We will take, let's see, somebody does have, where does SO get the threat intelligence rules?
Security Onion uses with Kibana, it uses the snort rules that are available on on the open source emerging threat rules. We also subscribe to a service for ET Pro from Proofpoint, which gives us more sets of rules.
Right. All right. If anybody has any further questions, please feel free to email Mr. Tran, and we will take a 10 minutes break, and we'll be back with our last presentation for today in 10 minutes.